Okay, this is lecture 19 notes, radical signs. Right, let's just review. So in general, I need to get my pen. In general, we have this. I have this sign called radicals. And inside, we call radicand. And me has a power n, index m. And so this we can write as a rational exponent as x raised by n over m. So we see the exponent is a fraction. The numerator is the power, is this. And the denominator is the index. So we call m index. Index. We call n exponent. Yeah, let's try always remember, what does it mean, index? What does the index do? But you have this, x doesn't have an n exponent. So if this equals to y, equivalently, this means y to the nth power is m. No, it's x. Y to the m's power, because my index is m. Y to the power m equals to x. Okay, that's what it means. All right, and this n can fall upon x or can be outside. So we may have index first, then this whole thing raised by n. So this one is the same as this one. All right, so both of this during the calculation, we want to write it as a rational exponent. Now let's see A. Right. A, we don't see index, right? So let's figure out m. M is 2, right? By default, if there's no number there, by default it's 2. And what's the power of 5? Or by default is 1. So in this case, we see x equals to 5, n equals to 1, m equals to 2. Right? Same thing for 7. So what can we do with this? So how do we multiply these two? So same index, that means we can put under 1 index. We can put 5 and 7 together under 1 square root. So 5 times 7, 35. So 35 square root. What does 35 square root mean? Means if we square this number, we get 35. What does square root of 5 mean? So let's try to understand those numbers. Those numbers are called irrational numbers. So this number is not 5, it's a square root of 5. Means if we square this number, we get 5. Or if we multiply this number by itself, we get 5. Okay, that's what this number is. Just let's make sure this is a square root of 5. It's not a 5. Now let's see B. B, the index is 5. That means I can put a radicand together. I can multiply those two radicands, right? Because the operation is multiplication. So I can multiply 3x with 2x squared. Then under the index 5. Now 3 times 2 gives me 6. X times x squared. Same base, we add the exponent. By default, exponent of x is 1. So I have x raised by 3. Then with the index 5. All right, so B is this one. Now let's see 2. 2 we want to simplify. So square root of 90, I can split 90 as 9 times 10. Right, you see I do the opposite with this 1a. 1a, I multiply those two together. But here I want to simplify, I split 90 into 9 times 10. because I know square root of 9. So I can split as square root of 9 times square root of 10. Square root of 9 is a 3 squared. Square root of 3 squared. Right, then times square root of 10. Square root cancel each other. Right? Think about like this. Think about this one in this form. The exponent is the numerator. The index is the denominator. So for 3 squared, the square root, we get 3 raised by 2 over 2. Well, 2 over 2 is 1. So that's why we get 3 raised by 1. So 3 radical 10. Now let's see B. B cubic root of 40. 40 can be split as A times 5. Right? So I can split this into cubic root of 8 times cubic root of 5. So cubic root of 8 is 2 raised by 3. Again, I have m equals to 3, n equals 3. 3 divided by 3 is 1. I have 2 raised by 1. So I have 2, oh, this is a cubic root. 2 times cubic root of 5. Let's see C. We want to simplify. So the index is a 3. But the exponent, we have 10, we have 15. And the 16 can be written as 2 raised by 3 times 2. Right? Because the index is 3, so I'm looking for the exponent to be 3, 6, 9, 12, 15. You see, those numbers are multiples of 3. So when I do, so those numbers are n in the formula, n, right? M is 3. So I would get 3 divided by 3, I get 1. 6 divided by 3, I get 2. 9 divided by 3, I get 3. 12 divided by 3, I get 4. 15 divided by 3, I get 5. So on and so forth. So that's why I like to split the radicands to have the exponent of multiples of 3. So x raised by 10, I want to split to x raised by 9 times x raised by 1. Y to the 15, I don't have to do anything because 15 is a multiple of 3. Now, let me change my color. So let's see. So those ones with exponent with which is multiples of 3 can be simplified. You see this 2 raised by 3, then index is 3. 3 divided by 3 is 1. So I have 2 raised by 1, right? X raised by 9, so I have this one. 9 divided by 3, which is 3. So I have x raised by 3. Y raised by 15. 15 divided by 3 gives me 5. So I have y raised by 5. Then what's left inside? I still have a cubic root of this 2 left and this x left inside. So cubic root of 2x still inside under the cubic root. So cubic root, square root, it's the index, depends on the index. If the index is 2, it's called square root. If the index is 3, it's called cubic root. If the index is 4, it's called fourth root. If m is 5, called fifth root, so on and so forth. Okay, so C simplified to be 2x cubed y raised by 5, then cubic root of 2x. Now let's see D. So D, we have 5 times 10. Well, what's 5 times 10? 50, right? The operation is multiplication. You see the operation is multiplication. So 5 times 10, that's 50. Now, under the cubic root, I have 2 and I have 16. So I have cubic root of 2 times 16. Remember, 16 is 2 raised by 4. right? So 2 raised by 4 can be simplified. Have cubic root of 2 times 2 times 2 raised by 3. 2 raised by 3, then with the index 3, that becomes 2. So 50 times 2, that's 100. So I have 100 cubic root of, and these two still left inside to be the radicand. So 2 times 2, that's 4. So it's simplified to be 100 cubic root of 4. And cubic root of 4 cannot be simplified further. So we're done. Now let's see 3. 3, we want to add and subtract radicals. So I want to add and subtract. When we add, when we subtract, it's similar to fractions. When we do fractions, similar to polynomials, right? If we have 3x plus 2x, we know we get 5x, right? If we have 2y minus y, we know this is 2 minus 1y, which will get a y. So same thing as irrational numbers. So square root 10 is irrational. Let's understand square root 10. That's in between of square root of 16 and square root of 9. So which means it's bigger than 3, but less than 4. And it's closer to 3 because 9 to 10 inside the radicand, only 1 apart. But 10 to 16, the inside radicand 6 apart. So we know, square root 10 is a 3 point something, right? Less than 3.5 because it's closer to square root of 9. But that's approximation. We don't want to do approximation anymore when in college. We want to keep as it is, because if we keep as it is, it's accurate. It's not approximation. So, let's get used to this notation. Square root of 10, it's just an irrational number. So we have addition here. So we have 5 of square root of 10 plus 3 square root of 10. Think as 5x plus 3x, so that we get a radical 10. And we call this like radicals. Like radicals. Because this term has square root 10, and this term has square root 10. So those two are like radicals. So we can add them. So 5 plus 3, that's 8. So I have a of radical 10. Now let's see b. B, we see we have cubic root of 5, right? That's like radical. And this one we have 3 up front. So what do we have this one? So negative sign we can understand as a negative 1. So think of 3 minus 1 of cubic root of 5, which is 2 cubic root of 5. Like radicals. All right, now let's see C. C, we have square root 48, we have square root 27. They don't look like radicals. So maybe we can try to simplify it. So let's see. So we have 3 times now. Square root of 48 can be split as 16 times 3, right? Then 2 radical 27 can be split as 9 times 3. Now we know square root of 16, which is 4. So we still have square root 3. Plus 2 times square root 9 is 3. Then radical 3. Because we have this 3 left in the radicand. We have this 3 left as a radicand. So we have radical 3, radical 3. Now we have like radicals. So 3 times 4, that's 12. The 12 radical 3. But 2 times 3, 6, radical 3. So we have 12 plus 6, which is 18, radical 3. Okay. Now let's see D. D, the index is 3. Index 3. Let's see. So 54, we can split into 9. Actually 27, because this is cubic root. We're looking for cubes. 27 times 2, right? But x3, then index 3. So exponent and the index the same. So we get the x out. We get a 6x, right? Then inside cubic root, we have 27, which is 3 cube times 2. Well, 3 cube means 3 comes out. 3 times 6, 18. So 18x, then the radicand with the left with the 2, cubic root of 2. Now let's see cubic root of 16. Cubic root of 16 can be thought as cubic root of a times 2. Then cubic root of a is 2 cube. Plus, okay. 2 cube, cubic root cancel out. So we have 2 raised by 1. 2 times 2, 4. So we get 4x cubic root of 2. Now we have cubic root of 2 as like radicals. So we just add 18 and 4. Cubic root of 2. Well, 18 plus 4, 22. So 22 cubic root of 2 as an answer for this, as a simplified version of it. Now let's see 4. Division. So division. Let's see 8. Both, oops, I need to get my pen. Both under square root. So we can pull this numerator and denominator under the same square root sign. Now we can simplify. A divided by 2 is a 4. X cubed divided by x squared. Right, when we divide to same base, we subtract the exponent. So 3 minus 1 by default, the exponent of x is 1. 3 minus 1 is 2. Now square root of 4 is 2. Square root of x squared is x. So simplify to be 2x. Let's see B. B is all under cubic root sign. So we put all under cubic root sign. So we have 24, x raised by 6, y raised by 5, divided by 3x cubed y squared, all under cubic root. Okay. Now we can simplify. 24 divided by 3, that's 8. X raised by 6 divided by x raised by 3. 6 minus 3, that's 3. Y raised by 5 divided by y squared. 5 minus 2, which is also 3. But 8 can be written as 2 raised by 3. So this one, so 2 raised by 1, x raised by 1, y raised by 1. So we got 2xy, right? Because the exponent and the index are the same. When we divide them, we get just 1. Let's see 5. We multiply with monomial with binomial, right? One term with 2 terms. So we distribute. Square root 3 times x. Yeah, I like to leave x in up front of the radical sign. Then plus square root of 3. Now square root of 6 can be break into 2 factors. Square root 3 times square root 2, right? What is square root 3 times itself? That's 3. it becomes 3 radical 2. Then add the first term, x radical 3. And that's it. We cannot do anything further to have an x radical 3 plus 3 radical 2. B, we have binomial. So we multiply first with first, second with second, second with first, first with second. Right? Square root 2 times 4, we get a 4 radical 2. Negative x times square root of ax, negative square root of ax squared. Right? Now, what's square root of 8? Let's pull on the side. Square root of 8 is square root 2 times 2. Square root of 4 is 2. Square root of 2 radical 2. So I have 4 radical 2 minus 2 radical 2x squared. Can leave like that. Now let's see C. C, we do the same thing. We multiply these two, we multiply these two, then we multiply these two, then we multiply these two. So 2 radical 3 times 3 radical 3. Let's put on the side. 2 radical 3 times 3 radical 3. We multiply 2 with 3, we get 6. Right? These two, this 3. Then radical 3 times radical 3. Remember, radical 3 means if you multiply by itself, you get radicand. So we get 18. So when we multiply 2 radical 3 with 3 radical 3, we get 18. So let's write on top of here. Now, 3, let's pull here, 3 radical 5 multiplied by negative 2 radical 5. 3 times negative 2, negative 6. Radical 5 times radical 5, 5. So we got negative 30. So let's write here, negative 30. 18 minus 28, we get minus 20. Now multiply those two. Multiply 3 radical 5, 3 radical 3. 3 times 3, that's 9. Radical 5 times radical 3, radical 15. Then multiply 2 radical 3 with a negative 2 radical 3. So we get negative 4 radical 15. So 9 radical 15 minus 4 radical 15. So we get a 5 radical 15. Radical 15 is just an irrational number. But what about for number? Number will get negative 20 plus. So in the end, C is negative 20 plus 5 square root of 15. Now let's see D. D, we do the same thing. Multiply first with first, second with second, second with first, first with second. Right? Radical 6 times radical 6. I hope by now you remember by heart. A radical number multiplied by itself is equal to radicand. So radical 6 times radical 6, that's just 6. Minus radical 3 times negative radical 3, just 3. So 6 minus 3, that's just 3. Why? Because the middle term cancelled. If the middle term will have square root 3 times square root 6, that's positive square root of 18. Then square root 6 times negative square root 3 is negative square root of 18. So one positive, one negative adds up to be 0. So D simplify in the end, just 3. Let's see 6. 6 is called rationalize the denominator. So when you go to calculus class, sometimes you may need to rationalize the numerator. But at this moment, let's rationalize the denominator. Why do we want to do that? Think about it. You have some apple shared by square root of 5 people. So how many people is square root of 5 people? You don't want to see that, right? Means one person has to be cut. into fraction. So that's why we want to rationalize. Because this denominator is an irrational number, it doesn't make sense. So we want to rationalize, which means we want to multiply by something. We want to multiply by something to make the denominator to be a rational number, 5. Well, remember, square root of 5 times itself is 5, right? Okay, so let's just do that. So we multiply 1, and this one is square root of 5 divided by itself. So the denominator will get 5 right away. The numerator will have, excuse me, square root of 2 times 5, which is 10. Now the denominator makes sense, right? Now we have some apples shared by 5 people. That's fine. That's easy to understand, but shared by 5 people. Okay, now let's see C. So we're gonna see B the last, because B, the denominator, is a binomial. Let's deal with the monomial first, which means 1 term. The denominator is just 1 term. So now we want to rationalize this. So also we want to multiply by something to get the denominator to be 9 is a 3 squared. So basically we have cubic root of 3 square x. So we want to make the exponent of everyone to have exponent of 3. So what do we multiply? We multiply cubic root of 3 squared needs 1 more 3. 3 raised by 1, right? 2 plus 1 is 3. The exponent will be 3. Now the x term is only x with the power 1. So we multiply x squared, because x squared times x is x cubed. So in that case, we have to do the same thing for the numerator. We get the cubic root of 3x squared. Now the denominator, we get right away 3x, because 3 raised by 3 and 3 raised by 3 and x raised by 3. So now it's rationalized. The denominator is 3x. Well, numerator, we just have to multiply, right? We have 2x times cubic root of 3x squared. And that's it. That's for C, right? So our job is to rationalize the denominator. And indeed, this is the denominator now is rationalized. The denominator is rationalized. Now let's see D before we do B, because the B denominator is monomial. So here I want to split, because the numerator and denominator all under cubic root. So I split as cubic root of 4 in the numerator, then cubic root of 5x squared in the denominator. So similar reason, we want to multiply cubic root of, here only have 5 raised by 1. So maybe we do 5 raised by 2, because 5 times 5 squared, that's 5 raised by 3. The x squared is there, so we only need to multiply by x. So we're going to do the same for the numerator and for the denominator. Cubic root of 5 squared x. Now, cubic root. So let's look at the denominator first. So I have 5 raised by 3, then cubic root. That becomes 5. I have x squared. Now multiply by x. It becomes x, because x cubed and cubic root cancel each other. So 6x in the denominator. The numerator will have a cubic root of 4 times 5, 20. Oh, 4 times 25, because we have 5 squared there, right? 100. 100, then x. And that's it. Now the denominator is rationalized. I think that finishes this lecture notes, but let me just double check. Yeah, that's it. Okay, I hope you missed class and this could be a help for you.